again, nothing is single on the left side of the equation. Carbons with oxygen, irons with oxygen here, so nothing is single. However, number 4 down at the bottom is single replacement. Aluminum is single on the left side. It takes the place of hydrogen. So now hydrogen is single and aluminum is with sulfate. Real quick before we move to the back, I just realized we missed one of our decomposition reactions. Number 4 at the top is also decomposition. So remember, you have one reactant and then 2 or more products. All right, flipping to the back, looking for single replacement reactions. The only one I see is number 6. So you'll notice that phosphorus and nitrogen switch places. So now phosphorus is with oxygen, nitrogen is by itself. And that is it for that. All right, now things are going to get really complicated. So for this next type of reaction, this is called double replacement. This is when you start with 2 compounds and the compounds end up switching partners and you end up with 2 new compounds. So my equation is going to be AX plus BY yields AY plus BX. So notice A and B are always in front. A and B are cations. X and Y are always second, so they are anions. And notice for your equation, you can never have 2 cations together. A and B are never together. And you can never have 2 anions together. X and Y are never together because they're both negative. So the weird analogy for this would be if you had 2 couples that decided to switch partners. And they were somehow okay with that. Again, I hope that this has never happened to you. One more thing I want to say about double replacement before we start identifying them. There is a specific type of double replacement, and I'm going to write this one down at the bottom. And this specific type of double replacement is called an acid-base reaction. So in acid-base reactions, you have an acid that reacts with a base. And when they react, you probably know that acids and bases neutralize each other, so you form water. And then the other product is a salt. Now you might be thinking table salt, like NaCl. Not necessarily. Salt is defined as a cation and an anion. How are you going to identify that something is an acid? It's going to begin with hydrogen. And how are you going to know that something is a base? It's going to end with OH. And that's how we get water. The H and the OH come together to make water. So we'll probably see an example of that in just a minute. All right, so let's look back at our sheet. We are looking for double replacement reactions, and I don't see any on the front of our sheet. So let's look at the back. Number 2 is a double replacement reaction. The way I know that is calcium and hydrogen switch places. So now calcium is with sulfate. Remember, if we want to look at our equation, this is AX and BY. And on the product side, we have AY plus BX. So you start with 2 compounds, you end with 2 compounds. For double replacement reactions, nothing is single. And then another one that is double replacement would be number 5. You start with 2 compounds and you end with 2 compounds. You might be noticing some other equations on this sheet we haven't identified yet. They will either fall into our last category or they won't be anything at all that we have discussed. I do, however, want to just give you an example of an acid-base reaction. If you had something like this, HCl plus NaOH yields H2O plus NaCl. All right, you would see that this is our acid. It begins with H. This is our base. It ends with OH. The H and the OH come together to make water. And NaCl comes together to make a salt. It doesn't always have to be this particular salt. Again, it's just a cation and an anion. All right, our last reaction is combustion. Now, combustion reactions you're probably familiar with. Anytime you burn something, anytime you drive a car, anytime you heat your home. Basically, burning fossil fuels to get energy is an example of a combustion reaction. So you start with a hydrocarbon. You might remember what a hydrocarbon is from our quick organic lesson. It's just something that contains hydrogen and carbon, plus O2, oxygen gas. Remember, you can't have fire without oxygen. And then your products are always CO2, carbon dioxide, and H2O. So our equation for that is going to be CXHY plus O2 yields CO2 plus H2O. So notice that oxygen, carbon dioxide, and water are always going to be the same, but the hydrocarbon might be different. You might have different subscripts next to the carbon and the hydrogen. Now, if we look back at our sheet, the only combustion reaction on here is number 3 at the top. And you may remember me saying that those are the ones that can be difficult to balance. Remember, this is the one that we ended up having to double everything to make it work. But again, I just want to point out, here's your hydrocarbon, carbon and hydrogen. You've got oxygen as the other reactant, and then on the product side, you've got carbon dioxide and water. Now, the other equations on this sheet, like number 3 at the bottom, and then number 10 at the bottom of the back, those don't fall into any of our categories, so don't worry about those. I'll make it pretty clear to you for your quiz. It'll be one of the ones that we have talked about. So anyway, that is your lesson on classifying reactions. If you would like more clarification, there's another lesson on YouTube where I go through the actual PowerPoint. So feel free to view that one as well, and please let me know if you have any questions.